Welcome everyone to today's Tech Excellence session. My name is Ollie, and today we are very happy to be joined by Emily Bache. Emily is an independent consultant, YouTuber, and a technical coach with 25 years in software development. She trains developers in agile practices such as refactoring and test-driven development, is an author of 2 books, teaches on Pluralsight and O'Reilly, speaks at top conferences, and founded the Summon Technical Coaching Society to promote technical excellence and support coaches everywhere. And in today's session, she will demonstrate how to effectively test legacy code. But before we get started, let's briefly also introduce ourselves. So we are Tech Excellence, and our vision is to raise the bar of technical excellence across the world. Via Valentina is our founder and organizer, and she is joined by Daniel, Alina, and me, who are co-organizers and co-hosts of these sessions as well. You can find us on basically all the social media like YouTube, Meetup, LinkedIn, GitHub, X, and also Discord, where you can also discuss with other mind-like people about technical excellence. Our sponsors are Optivem and CodeArtify, and our partner is QE Unit. And lastly, before I hand over the mic to Emily, I want to remind the audience that you are very much encouraged to write down any comment, observation, or questions you have in the comment section below, and we will make room to discuss them at the end of the session. And now, Emily, the stage is yours.
Thank you so much. I'm very pleased to be invited to join this meetup, and I hope that you will take Oliver up on that suggestion and write some comments in the and questions in the open field there. And I'm going to present for something like an hour, and then there'll be another half hour where we can discuss anything you want to discuss about. So I'm going to be talking today about legacy code and how to test it, which are issues that I'm very interested in, at least. So let me just find my my controls here so I can show the next slide. So here we go. I already got an introduction from Oliver. I just wanted to recap what he said. Basically, I have a YouTube channel. I've written a couple of books, the most recent one about technical coaching. I'm on social media with this handle, Emily Bache, and you can email me if you really want to. So this talk is, to some extent, a kind of expanded version of this video I have on my YouTube channel that came out a few weeks ago. Don't worry if you haven't seen it, because we're going to be going through a lot of the same materials, but just in a lot more depth. I mean, that video is like 15 minutes long, and I've got an hour. So I can really geek out on some of the things that I had to kind of gloss over in that video. So what you're going to learn about tonight is what is legacy code? How are you going to write tests for legacy code? The tests that you want to write but can't. And then we're going to look at combination approvals, which is an approach that I really favor. And then talk about the Kent Beck's test Desiderata and how that kind of helps us to reason about tests for legacy code. And other code, of course, as well. So that's what's coming up in the next hour. So I just wanted to explain a little bit about my background first. I'm a technical coach. I work with development teams to teach coding skills and build engineering culture. That's my main job. And I have been doing this for a number of years now. I've been working with a lot of largely European software companies, 5 or 6 years of doing that full time. Before that, I was doing various other coaching activities alongside working as a software developer. And I've been, as I've been coaching, I've been pair coaching with other technical coaches from around the world, which has meant that I've got exposure to a lot of experience of how to do coaching, and I've learned from my other pair coaches. And so I feel that I know quite a lot about this way of helping development teams. And that's why I wrote a book, basically to try and encourage other technical coaches that there are good ways to do this. So this is a concrete, practical book about how to do coaching, and I named it the Samman method so that you can Google it. And Samman is a Swedish word meaning together. I live in Sweden. I do all my coaching remotely though, so it's geography is not so important these days. But yeah, what I do is I train and mentor software teams. So since the book came out, I founded the SAMAN Technical Coaching Society as a resource for technical coaches everywhere. We've got a lot of things available for free on our website. We've got these monthly open space meetings. So if you're interested in technical coaching, do head over to samancoaching.org. And we've got an open space next week, actually, so that you could come along to. And there you can find code katas and learning our materials and about our training courses that we have. So if you'd like to learn more about technical coaching, that's a good place to go. But today we are talking about more about specifically legacy code. And this is something that comes up often when I'm coaching. I go and work with a team and I look at their code and I think, okay, this is a difficult situation. And a lot of the time they're well aware of this. And what we see in this code, how we know we've got difficulties, is we've got technical debt. And technical debt's a term invented by Ward Cunningham. And it's a term that I think has drifted a little bit in meaning since he came up with it. And I prefer this description of it from Martin Fowler, who says, technical debt is deficiencies in the internal quality, that is the design of the code, that make it harder than it would ideally be to modify and extend. So it slows you down. So that's not my sketch there of a person being slowed down by this weight. And that's what happens. The teams I go in and coach, they're finding it really difficult to make progress and add features to this code, because the design is not set up in a way that supports easily adding new features. And what we all want, actually, is to be able to deliver more features sooner and be able to work with that code and be productive and get that value in the hands of the users of the software. So we would like to minimize the amount of that technical debt slowing us down. I mean, I don't think we can get it to zero. You're never going to get the ideal design that's going to be perfect for adding whatever feature you can think of. But I'm sure that most teams can do better than where they are. And if you've got a lot of technical debt, then it can be really worthwhile learning some techniques to deal with that. So there are techniques for handling legacy code effectively. And one of the ways to learn those techniques is to look at code kata. So maybe you're not familiar with the idea of a code kata, but it's a piece of code that's designed to have some characteristics of code that are like legacy code or technical debt that you have to deal with, at least when it's a refactoring kata like this one. This is the Gilded Rose. If you haven't seen it before, let me just slowly scroll through this code. And I'm hoping you'll be able to spot why this qualifies as legacy code. You can kind of see the level of indentation on that code and the warnings that the IDE is giving you that this is a stupid thing to do. Basically, there's kind of a lot of things that could be better about this code. In fact, this has already been improved a little bit. I'm showing you the version that somebody's already refactored a bit. I should show you the original. I've got it here. So the original is nearly the same with just more hard-coded strings in it. There you go. It's even worse. So I guess I'm showing you my editor here. I've got 3 versions of this that I'm going to go through tonight and show you different approaches and different ways to deal with this code. So this is an example of kind of a small, manageable legacy code problem that we can use to learn more about legacy code techniques. So one of the things that we want to discuss then is how we can write tests for this, because one of the things we want to be able to do, of course, is refactor this code, improve the design. But before we can probably do that, we might like to have some tests. I mean, it looked pretty hairy. I don't know about you, but before I go changing code that looks like that, I'd like to have a safety net. So Kent Beck came up with these test Desiderata to explain the desirable properties that he would expect tests to have. And it's so like a vocabulary for talking about good things about tests. So there's like 12 of them, and they're split into these 4 categories. And we're going to talk about several of them this evening. I keep saying this evening. You might not be in the same time zone as me, but for me, it's the evening. Sorry. I hope you'll bear with me anyway. This is really insightful, I think, from Kent Beck. And I just wanted to highlight, when you are refactoring something like legacy code, you really need your tests to have these two of the desiderata. They need to be predictive and they need to be fast. So fast is probably quite self-explanatory. You need to, because you're refactoring, you want to run those tests after every change. You don't want to be sitting there waiting for a very long time to get that feedback of whether you broke something. So for tests to be useful for refactoring, they need to run in ideally a few seconds, but perhaps you'd be willing to wait up to a minute at the stretch. So on that kind of time scale, though, for tests to support refactoring. Predictive is probably the most important of all the desiderata, actually. Predictive means that a green test run, passing tests, predicts that your code will work in production. So you can have quite a lot of confidence. If your tests are predictive, then you know that if you make a refactoring mistake, they're going to tell you, no, you've made a mistake. There's something wrong. You can't ship that. So predictive tells you whether the tests give you good information that leads you to make an accurate shipping decision about that code. So we need these, whatever. So the tests I'm going to work with in this session, hopefully, are all going to be fast and predictive. But apart from that, there are quite a lot of other desiderata that you could potentially prioritize. And because the thing is, you can't get all of them at once. It's like, so that's the thing Kent Beck said about this, that there's often a trade-off between pairs of them or more than one of them. So you need to decide what's most important for your situation. How are you going to design those test cases? So tonight I'm going to go through different ways of doing this that have different trade-offs. So the first approach I'm going to talk about is ordinary unit tests, adding unit tests after the fact to this legacy code. And the way that I've seen a lot of people try to do this, and I've been on like GitHub and searching around trying to find good examples. But this is the most common approach that people have. And I don't necessarily think it's the best approach, but this is how people tend to do it. Now, the Gilded Rose code comes with a requirements specification. I didn't show you this before, I'm showing you now. So this is kind of the backstory for where this code comes from and what you're trying to do. So it says at the start, welcome to Team Gilded Rose. And that's so it's kind of drawing you into this fantasy world where you've just started your job working with this piece of code that's designed for this inventory system, where all the items in the inventory are kind of magical and do strange things. But at the fundamental level, you're trying to keep track of the quality of all the items in their system. And every day, it needs to run this procedure that will update the quality of all the items in stock. So they can work out, how valuable they are, I guess. So the magical element comes from it's actually World of Warcraft, I think. It's a computer game. But you don't need to know anything about that. I've never played it to enjoy this code kata. So that's the kind of requirements specification. So if I just go back to the code, maybe I'll go back to the original version of the code here. So this is the function that gets called each day to update all the items in the inventory. So it's going through all the items and it's updating the quality according to some weird business rules. And it also updates the sell-in, which is another property of the item, which is keeping track of how soon is it basically until we need to sell it, like the best before date. And then so this logic is so fun to work with. It just looks so horrible at the start. So basically what people do then is they take the requirements document and they write unit tests for this. So this is one example that I found, which I have to say is a particularly well done example. This is code by Daniel Steinberg. I've got a screenshot of it here. He's got on GitHub a 42-part article about how to solve the Gilded Rose kata, and it's actually very good. I read all of it, and I think he's got some very good approaches and very good advice. So of all the solutions I found on the internet that use this approach, this was like the best one. So if you're going to read any of them, look at this one. So anyway, he has written these tests based on the requirements spec that comes with the code. So he's like, items have names and sell-ins, and they decrease at the end of the day, and the quality decreases. So he's done a lot of work on these. And actually, if you look at these as examples of unit test design, he's using all of the techniques that you'd recommend for unit test design. He's got these kind of helper functions, creating an app with a single item, and then calling the method update quality, which he's renamed to update at end of day. That's the production code that we were just looking at. And then he's got these fluent assertions with all of these, assert that when you get the loan item, its quality is the arbitrary quality plus 2. I mean, this reads really well. So he's really invested a lot in readability and making it very clear what all of these are testing. So if I just run these, I'll just show that they run very quickly. He's got 25 of them, and you can see they've all got really nice names, and they're all really short and stuff. So actually, if this is a really good example of this approach. I think I was going to say some more about it. Yeah. I was going to say, so I already went through one of the tests. They all look like this, basically, with the kind of arrange, act, assert, fluent assertions, helper methods, great stuff. Now, the criticism I have, basically, of all this is this was a lot of work to create these. And he's had to really read that requirements specification very carefully to be able to write these tests, as well as running the code and running the tests and seeing what it does. He really needed to lean on the requirements specification quite a lot. And for legacy code in general, there might not be a requirements specification, or if there is one, it might not be very good or very accurate. And you might not want to spend quite so much time and attention retrofitting tests as he's needed to spend here. Because this was a lot of work. I wanted to also point out something he's done really well. I've drawn this graph with 3 axes to try and explain how I think about the things that can affect the results. So when you update the quality of an item, the result will depend on what kind of item it is. So that's this x-axis here, the item type. And then on the y-axis, the other thing that affects the result is, well, how long is it left until the sell-in expires? 10 days, 5 days, 0 days. These are kind of interesting points where something different happens, whether it's before 10 or after 10 or before 5 or after, So I've just put in the important values. And then, of course, what happens to the item also kind of depends on what the quality was before. And what the limits are on the quality. So there's these 3 axes things that are varying. So in order to conceptually test all of the functionality, you need tests for, normal items, quality below 0, sell-in below 0, brie items, quality below 0, sell-in below 0, and so on. And then you also need to test the same 4 items for quality above 0 and quality like at 50 and quality above 50. And then you need the same items for sell-in at 0 and at 5 and at 10 and above 10. And you end up with a lot of points on this graph where you could potentially need to have a test case. There are a lot of combinations here that in order to properly cover yourself from breaking any functionality that you might want to actually test. And what Daniel has done really well in his test is he hasn't written a test for all of these. He's very carefully read the requirements and picked out, actually, these 3 I need to have, and I'll write those tests. But a lot of these other ones actually aren't very important. And he's done that kind of for every aspect. And that's why, even though conceptually you need a lot of tests, he's got 25 and he's got good coverage of the functionality. But this was a lot of work. Okay, so that's kind of profiling the first of the 3 code examples that I've got here, the 3 tests examples. I want to talk a bit more about my second example, which is a bit different. The second approach here is to basically rewrite the legacy code from scratch, do it properly, do it over with a new design, with tests, and you can get then a much better design. So I've got a little demo of this. So the way I do demos is that I record myself doing the typing, so that when I'm in the presentation like now, I can concentrate on the talking. I don't like to have to talk and type at the same time. So this is me still typing, but it also means that I can speed up the typing a little bit. I think I've just sped it up like 20%. I usually do that. So this is me with an empty Gilded Rose class and an empty test that clearly fails. And I've got just a list of test cases. And I came up with this list of test cases by looking at the requirements document and by thinking about what needed to be implemented. So the first test case is there. I was just going to take you through this a little bit, actually, how you would attack Gilded Rose as a from scratch TDD rewrite. So the first thing, of course, is to make sure your test framework is all working. So I'm just running the tests. As expected, this test fails. It's not a good test. So let's rewrite this to instead test a normal item. When you call update, it will lower the quality. So that's the first test case. And then I need to actually write some code here. So I usually start with the assertion. So when I call get quality on my item, it should be 2. That's a very arbitrary value. So let's construct that item and tell it that its quality starts out as 3, so that it should get reduced to 2 when I update the quality. So let's call that daily update method. So that was me doing some design in my test case and deciding that I'm going to have a class called normal item with these methods. So now the next part of TDD is basically to get this to compile. So I'm just going to go and create that class, and my tool can help me with that. So it'll even put it in version control and prompt me to name my variables properly. So I like to keep the code and the tests on the screen at the same time if I can. So anyway, there's the daily update method. I won't implement that yet. I'm going to make it compile first. So let's implement that get quality method. And actually, it gave me a property. I don't think I need a set method for that. Okay, and then I want to take that constructor argument and put it in the field. Okay, so run the tests. Now I'm expecting this to fail because I haven't implemented the daily update method. So yes, it fails. So it compiles and fails, and I expected 2. So let's go and implement that daily update method. I need to decrement the quality. So this is where I expect the test to pass. And it doesn't, because I knew this. I recorded earlier. I made a mistake in the constructor. I believed my kind of AI prompt thing that did the wrong thing. I clearly need to update the field and not the variable itself. I don't know why. But anyway, now I fixed that. Hopefully the test will pass. Great. And I can cross that test case off my list, and I can do a bit of refactoring. Actually, I think this is an entirely arbitrary number. So I'm taking inspiration from Daniel's test here, actually. I think it's a good thing to name that arbitrary quality. I think that reads a little better. Okay, so that test is still passing because it was a refactoring, and then I should just make a commit. It's when I'm doing TDD, it's nice to commit when the tests are passing. Okay, and then I go to the next test on my list. And the next test. So at this point, I think I'm going to skip ahead a little bit. You watching me do TDD is great, but I think it gets more interesting when I get to the 4th test. So I'm just skipping ahead here to a little bit further. Yeah, so there's the commit for the 3rd test, where I've implemented the daily update method to the point where I'm decrementing quality and sell-in, and if the sell-in has expired, then I'm decrementing the quality in extra time. So I'm starting to get the business logic in place for normal items. Okay, so the next test on my list here is that the normal item quality shouldn't go below 0. And that seems to me like the daily update method just at the end here. I need to check that. But I was thinking about it some more and realizing, actually, I don't think this functionality really belongs in this method just here. So I'm doing a bit of design in my head and thinking, well, what do I want here? I think what I'd quite like is to be able to write something like, why don't I have a quality boundaries object that was responsible for this, and that I would be able to tell it to restrict my quality to lie within the boundaries that I've got. So, and I could make that a different object. So I'm thinking about here dividing my responsibilities and developing new code in a new class. And I'm doing it from the place I was expecting to call that new functionality from. But rather than just going ahead and doing that from here, I'm just going to comment that out. That was just me kind of sketching my design. And now I'm going to go back and write a test that's going to prompt me to do this. So this is the next test here. I'm going to write a test called quality boundaries, because that's the new class I'm thinking of. But it should restrict the quality to not go below 0, basically. So let's see how this is how I wanted to use it. So let's put that here. I need to adjust this to work in the test, of course. So it's going to return a new quality, and I need to give it the quality that needs to restrict. And if I give that a number above 0, then of course it should return the same number. So let's put that assertion in. So the new quality should be the same as it was before for numbers above 0. Okay, so again, I need to use my tools to create that object. I've done the design in the test. The test is helping me with my design as well as the sketch in the production code. And now my tools can help me to create this class. So again, I need to have a method on this, restrict. It's going to return an integer. I can name my variables. And then I'm just going to run this to see it fail. Of course, it's good to, when you're doing TDD, to see the test fail. Great. So now I can actually write the implementation. And that should pass. Yeah, great. So, and at this point, I'm thinking, well, let's just inline that. This, I'm being a little bit lazy here, actually, because I realized the next test case is for a number below 0, and I thought, same test case, I'll just write another assertion in it. I probably should have written another test case for this. But I felt it's the same kind of functionality. And let's do actually on the boundary value as well. So 0 stays 0. And let's see, now this should fail. And prompt me then to write more implementation. So at this point, I should write something that's going to work for all of those 3 cases I've got there. So what if I use math.max? Okay, and then that should make those tests pass. Yeah, so there I've implemented some quality boundaries, and now I can go back here and put this bit of code in and get this to work and continue the TDD. So that was a kind of an excerpt of the TDD that I did when I created this implementation of Gilded Rose, which and this one is, I think it has the same functionality as the original Gilded Rose. And as you can see, my quality boundaries test has gained a max 50 boundary as well. And I've got classes for all of the different kinds of item, and they are using the quality boundaries to restrict the quality. And I've got this in the normal item and the aged brie item, sorry, the aged brie item there, and the backstage pass item. So I just wanted to highlight this aspect of the design means that I've separated out that functionality from the rest of the design. And I've got tests for all of the functionality that I wrote with TDD, and I've got, does it say yes, 18 tests. So I've managed to implement the same functionality that Daniel's writing tests for here with TDD with fewer tests. And a better design, of course, as well, because it's I've got lots of small collaborating objects instead of one huge messy looking function. So that's another way of handling legacy code, is to rewrite it with a nice design. That might not be a luxury you have, but it does have some positive effects. So this is the sample test that we've got of the quality boundaries here. And I wanted to highlight the way that this means that those 3 axes that I had to test all the combinations of before, because of this design decision to separate out that quality boundaries object, I now have the ability to check the logic to do with the item type and the logic to do with the quality boundaries separately. I don't need to test all the combinations of them. Actually, I've drawn it like this, that the sell-in is separate as well, but I think that's slightly ambitious. I think actually the item type and the sell-in, you have to test those together. At least the way I did it. Maybe you'll do it differently. But the point is basically that I've escaped the combinatorial explosion by having a better design. Now I want to talk about the third approach, which is basically embrace the combinational explosion. We're going to use combination approvals. So this is, let's talk about composability a little bit later. Let's do the demo. Okay, so I've got the end state of the code here, but I wanted to give you an excerpt of how I got there. So I've got another demo that I've recorded. So this is me starting from, this is not an empty editor. I'm starting here from the Java approvals folder in the Gilded Rose project. Hopefully you can find the Gilded Rose code on my GitHub, and there's a folder for each language version, and there's actually a folder for Java and then a folder for Java approvals, and that's this one that I'm looking at here. So the update quality test that you start with is quite bare bones, but it actually doesn't even pass. So this is an approval test though. So this line 18 here is approvals.verify, and I'm passing it the item which is supposed to have been updated during this test. It's this item I created up here, foo, with sell-in 0 and quality 0, and at the end I'm just sending that to approvals. So if I run this test, as I said, it does actually fail, and that's normal for an approval test if you haven't previously approved anything, which I haven't here. So it helpfully brings up this diff and says, okay, on the left there, that's the text that I received. That's the item toString, basically. It's item number foo with this sell-in and quality. And then on the right is the empty file of what I approved earlier. I didn't approve anything earlier. So what I want to do is say, well, yeah, this, whatever it does is probably correct. It had sell-in 0 and quality to start with, and something's happened to the sell-in at least. So I guess that's right. It's legacy code. Whatever it does is right. I'll just approve that by copying the contents of the receive file to the approve file. Okay, so now I've got a test that at least should pass if I run it again. But I'm just going to do a small refactoring here to make it explicit that I'm calling toString in order to print that item, and then extract that to a variable. And then I'm going to rename it, yes, and show you the implementation of toString. It's pretty basic. I think this is even, it might even have been generated by the tool, I'm not sure. But I'm basically thinking I can do better. I'd like to improve on this. So I'm going to copy that, and I'm going to make a new function here in the test, which I'm going to call item printer, which is a function that's going to take an item and it's going to return a string representation of that item, much like toString, only now in the test I've got full control over what text it's going to produce, and I might like to produce a text that's a bit more informative. So I'm just going to add these labels to say, yeah, that one's the sell-in and that one's the quality, and I think that's going to make this test a little easier to read. So let's change this to use my new item printer. So this is one of the important things with approval testing, be in control of the text that you're approving. So I'll run this again. And there we are. That looks a little bit easier to read, that received text on the left. It's got these labels that make it easier to understand. So I'm going to approve that, copy it into the approve file. And then when I run the test again, it should pass. I think I forgot to do that last time. Yeah. So it's green now because the received text matches the approved text. So it passes. Okay. So far, this was just a demo of normal approval testing. But there's more. I want to show you combination approvals. But let's just make a commit with where we're at. This is, what did I do here? I made the initial approval tests for update quality and made it pass. Okay. So the next thing I want to do is look at the production code a little bit. So the production code I showed you before. Let's run it with coverage and see, because there's a lot of logic here. We want to make sure that when we're refactoring, we're not going to break any of this logic. And code coverage is a way of seeing which lines of code are actually being executed when we run the test. And that will give us a clue as to how confident we can be, how predictive we are, how predictive the tests are of whether we've broken anything. And if at the moment there's lots of red lines here and only a few green lines, so if we make refactoring mistakes in some of those lines that are red, our tests have no chance of finding that, basically. The compiler might find it, but the tests won't even be executing those lines. So this approach to adding tests is basically looking at, well, the first place, let's make sure we at least cover or execute each line of code that we want to refactor. In order to reach those lines, we're going to need to vary the name of the item, we're going to need to vary the quality of the item, and we're going to need to vary the sell-in, those three axes that I had on that graph earlier. So we want to have tests that are going to vary those things. So I'm going to start just by pulling out those three aspects as variables, because I want to vary them. So let's have named variables for these. And this also makes it very clear that the middle part of this test now, this part is doing the work of constructing, converting the variables into something that we can run through the production code and then get it back as a string. So I'm going to extract that as a function. And I'm going to call it do update quality because that's what it does. It does update quality with these variables. And I'm just going to change it. The tool made it a static function. I could have it as a static function, but I felt like I wanted a normal member function there. I'll just clean up that excessively verbose bit there at the end by inlining a thing. So that was a pure refactoring. My tests are still passing. I've just extracted this function. And now this gives me the opportunity to change the way I'm using approval testing. First, I'll just make a little commit there. So make sure that I can get back to working state easily. But now I can replace this way of doing approvals with a different way. I'm going to use combination approvals. And I'm going to call this method verify all combinations. And this, as you can see from the help text here, has got a lot of options. Yeah, don't look at that. The easiest way to explain this, I think, is that the first argument needs to be a reference to a function, a pure function. And that's the function I just created, do update quality. So I've made that's a reference there. The first argument there is a reference to that function. Not calling that function, it's passing the actual function. And then the additional arguments that I need here, I need one for each argument to that function, giving an array of items that would be able to be handed as arguments to that function. So this function takes a string and two ints. So I need to add additional arguments for a string array and two int arrays. And I populate them initially with the three variables that I have from earlier, the name, the sell-in, and the quality. And this doesn't compile, which is really annoying, and it's actually just a quirk of Java. Conceptually, it's doing the right thing, but it's using these integer primitives and Java unboxing, blah, blah, blah. Not sure, really, but it works if I change these to proper integer objects here instead of the primitives. So let's just do that and not worry too much about why Java complains about primitives. So that works. It compiles at least. And then when I run this test, it actually fails. I mean, conceptually, that was mostly a refactoring, but it wasn't really, because combination approvals work slightly different. You can see on the left here that it's added this additional text. It's put in these square brackets the arguments that it received to the do update quality method. And then on the right, that's the output that it got from that method, which is the same as we got before. So this is actually, I think, an improvement. It makes it clearer the scenario. We started with these arguments and we ended up with this item state. So I'm approving that. And then I can just clean up a bit. I don't need that. Actually, that is not being used. And this test just got a little bit shorter, maybe. Actually, it's not really shorter, but it's got potential though, because I'm just going to make a commit here. So I've got this as a checkpoint. But basically what we can do now is we can add more combinations. So if we go back to the code, in order to reach some of these branches that I haven't, that are red at the moment, I'm going to need more names of item. So let's take agebree and let's put that into my array of names. And then I'll run the test again and show you what happens. Instead of just one line in the output now, I've got two. I've got the original item and then an item called agebree. And if we look a bit more closely, you can see that it's behaved slightly differently than the other item. The selling's gone down to -1, but the quality has gone up to 2. And that implies that it's taken a different path through the logic in the code and come to a different result. So I should have increased the coverage and I should have better tests now that are going to give me higher predictive value. So I'll just run these again with coverage and see if I can see any difference in the coverage. Yeah, maybe I might have got an extra line or two. But actually, I've probably got quite a lot more to do. I need at least these other items that are named. There are 4 types of items. Let's just put them in. So we'll put those into the array. And now when I run the test again, it's hopefully going to give me more coverage. Yeah, look, I've got 4 cases now with those other names, and these ones are doing something different. Yeah, they've got different values. I'll just approve that. Everything that the legacy code does can be assumed to be correct. It's in production, people are using it. Okay, let's see what the coverage is like now. So I think it might be a bit better. Yeah, look, I think there's a bit more green. Still a few lines I'm not hitting, but there's more green here, look. And yeah, but I think to get more, I'm going to need to actually have more values for sell-in. So quite obviously, I'm going to need a sell-in below 0 to hit this piece of code at least. So I can actually go back here and let's just modify this a bit and put in another sell-in value. I've just inlined that one and added a -1. And since I no longer have named variables here, I should probably add a comment, make it really clear what's going on. Okay, so now I've got an extra value of sell-in. And when I run the test again, this time I didn't just get 1 new line of outputs, I got double the number of output lines, because of course it's testing all the combinations. It's testing all of those names of item with both of those values for sell-in. So when you add more combinations, it kind of increases exponentially the number of tests that you get, because each line here, you could think of it like a separate test case because it's doing a line-by-line diff. So I'm just approving that. And then let's see how the quality develops. Yep, that's looking good. And the coverage, still not covering everything. So at this point, I'm going to skip over a bit. I'm going to search through and try and find more values for sell-in and quality, looking at the coverage. And then a little bit further along, I get enough combinations for the whole of statement coverage. This is all green. And then I go and enable branch coverage, because that's a higher bar. I mean, the statement coverage means that it's gone to that line. But branch coverage will tell you, well, if there were 2 possible outcomes of that line, did it cover both of them? So again, I'm trying to find where my tests might not be predictive by getting them to show me where I'm not perhaps covering things as well as I might do. So this branch coverage lets me see now, when I was on this line of code, it was always true. My tests always had this as true. It says true hits 12, false hits 0. So from this, I can then work out that I need more variety in my input values so that this will be false some of the time, so that I've got better coverage. So I then go back and add a bunch more values to my lists here. So I need some high values basically to hit the top of that quality range. So I put in a few more of them, and same, I go and run this and see it fail, and I get even more combinations. There you go, even more combinations, and then I can just approve this. And yeah, and I get more coverage. And anyway, so I do some of that, and then I even do I get full branch coverage, and then I do some mutation testing, but maybe I won't need to talk about that for the moment. Basically, at some point I get full branch coverage, and anyway, what I end up with is this test. Basically, I thought I would gloss over the last steps there. It's a fun exercise. Do try it out. But you end up with quite, half a dozen values for silent and quality. And if I look at the approved file, there's a lot of combinations here. Each line of these is like a test case, and I've got 120 of them. I mean, there's surely some redundancy here, but basically I've tested everything, and I'm pretty sure that this is going to be helpful for refactoring. It's going to be predictive because it's got such good coverage, and as I just ran it and showed you, this is fast enough to support refactoring. Okay, so that was the demo of some combinations. So let's go back to the test desiderata, which I talked about earlier. I want to highlight composability. This is one of those desirable characteristics that Kent Beck talks about. And what this means basically is that if your tests are composable, then you don't need to test the combinational explosion of all the combinations. So the tests that I wrote for the TDD version are composable. The TDD version here from scratch, the tests are composable. I could test the quality boundaries completely separately from all the types of item. I didn't need to test all the combinations of those. Daniel Steinberg's solution, his tests are trying really hard to avoid the combinational explosion. So he's got tests for quality is never negative. And he's got quality boundary tests, kind of aged breed, quality never exceeds 50, and stuff like that. But he's had to very carefully work out that some of the combinations are impossible, and he hasn't tested those. So he had to do quite a lot of work analyzing the requirements to work out which combinations were valid and that he should write tests for. Because the design of the code is not composable. This is a mess. The logic for quality boundaries is all mixed up with the logic for different kinds of items. So fundamentally, the design of the code is not composable. And that's why it's so hard to write composable tests for it. With the combination approvals, you're like, well, yeah, the design of the code's not composable. Let's just forget that. Let's just test everything. Let's embrace the complexity here. So it's a different approach. So the approval tests are not composable, but the problem is that the design code under test is not composable. That's why this is a problem. Okay. The other thing I wanted to highlight from the Desiderata was writability. So I think that those approval tests score well on the writable Desiderata. The writability means how easy was it to write the test? How much effort did I have to put in? My basic argument is that I think these combination approvals were easier to write than the tests that somebody like Daniel was writing by analyzing the requirements. So I think that's the trade-off you're able to make with the approval tests. You get writability and you just say, well, what composability was too hard. Let's just not bother. And you end up basically trying to get, both these tests have got predictive, they've got fast, but they've got different amounts of writable and composable in the tests. Okay, so I've just got one more desiderata I want to talk about, and that is specificity, or test failures should be specific. So this desiderata is basically, you want your tests, when they fail, to point very clearly, this is the problem. This is where the bug is. This is what you need to fix. That's desirable, isn't it? I mean, because when a test fails, you don't want to be hunting around for ages trying to work out what's wrong. So you'd like your test to be really specific about the failure. So this is something that I would like to check, basically. I've got a demo. I've got 3 versions of this code. And I recorded this earlier just to make it a little bit easier. But this is the state of the code that I've got in my editor over there. So I've got these 3 versions, and the tests are all passing in all 3. I'll just start by running them all to show they all pass. And then I'm going to go in and introduce a bug. And the bug that I'm going to introduce is that the quality boundary at the top should be 50. That's the highest quality you should have. And I'm just going to replace that with 49. So in the Gilded Rose logic, it's going to replace 50 with a 49. So that's a bug. I'm going to, in this, my from scratch TDD version, I'm also going to introduce the same bug. The maximum quality is not going to be 50, it's going to be 49. And in this other version of with the approval tests, I'm also going to make that same bug, that 50 replaced with 49. Okay, so now let's see, how good are these tests? Are they going to find the bug? And how specifically are they going to identify it? So this is Daniel Steinberg's code and his tests. So I'm running these ones. And I've got 3 test failures. So full marks for finding the bug. But how specific is this? Well, the names of these tests are actually pretty good, I think. So we've got backstage passes quality does not exceed 50. Aged brie quality never exceeds 50. Backstage pass. So the common denominator of all 3 of these tests is quality does not exceed 50. And then I can see in the error message that 50 is 49. So this gives me a pretty strong clue just from reading the test names what's wrong. So that is actually pretty good on specificity, I think. Okay, so what about the from scratch version? If I run these tests, do they fail? Of course they do fail. Yes, they find the bug. And the test that's failing is called quality boundaries test. And the exact test that's failing is quality max 50. Again, just from the test name, that's pretty specific, isn't it? It's like, yeah. So that's pretty good. And then if I go and look at the 3rd example, let's go over to the approvals version and run the tests here. So yeah, as expected, they find the bug, which is great. So all 3 of these have found the bug, which is kind of basic. Now, there's a bit of a difference here, though, of course, because it's opened up this diff tool and it's showing me on the left is what I received and on the right is what I expected, what I approved earlier. So I can kind of see from the diff that I've got quite a few differences. These ones on the screen are aged brie. A 50 has turned into a 49. And if I scroll down and look at, there are more differences as well. So these ones are all aged brie. And all of them have the same thing with 50 turning into 49. And then a bit lower down, I've got some backstage passes. If I just scroll to the right so I can see what's going on, again, the 50 is turned to 49. And, you know, the diff tool is highlighting that for me, the 50 and the 49. So even though I don't have a test name that is pointing out quality is max quality was 50, should be 49. I mean, I think this is giving me that same message. It didn't take me very long of reading this to work out. So I think as far as error messages are concerned, it's not too, they're not too different from one another, just from the test failure. The next thing I want to look at, though, is it's not, I've got the general idea of what's wrong, but of course I need to go into the code and find the problem. So how specific the test message is also related to how specific in the code it can show me where the bug is. So if we look at more closely at like this test, the bug happens in the act step of the test, and that is the same act step in all of these tests. It's the line that does, I'm going to click on it in a minute, I really am. It's the line that does update at end of day. That's the big function. So you know that the problem is somewhere in there. So you go to there and you're like, oh, okay, this is a huge, horrible looking function. The bug is somewhere in here. So as far as specificity goes, I've got to potentially look through all of those lines of code to find the problem. And that's not the fault of the tests. That's because the design of the code is so bad and it's got this long function and the bug's in there somewhere. So that's kind of in contrast to this situation, of course, because I know that the bug is in the act step here. So if I go and look in the act step, there are 3 lines of code to look through. So suddenly that specificity is very good. I can immediately work out, that 49 should be 50. I can see that there's 3 lines of code to search through. And that's because the design of the code is better. It's not actually anything to do with the test, really. And for this one, again, the bug is in the act step. It's somewhere in this update quality method. And you can pretty quickly work out that it's somewhere in this horrible long function. So this code has got the same problem as the first one. The bug is somewhere in the code, and the code has such a poor design. The tests can't be any more specific. It's just the code is horrible. So I think this this points out the deep relationship between testability and design. I've showed you that basically you can't get really specific tests if your design of your code is poor, just like you can't get really composable tests if the design of your code is poor. Right. So anyway, hopefully the Gilded Rose has helped you to understand a little bit more about the test Desiderata and how to test legacy code. So I just wanted to round off with trying to draw some conclusions from this. So what we all want is more features sooner. That's good for us as developers. It's good for the companies we work for. And technical debt and legacy code holds us back from that because it slows us down, because the design of the code is not very good. So what we need is good tests for that code so that we can start to refactor and remove that technical debt. And in order to be any good for refactoring, your tests need to be predictive and fast. There is more than one way to achieve that. But if the design is very bad, it's hard to get other desirable characteristics of tests. It's hard to write tests that are composable or specific. So you're going to need to make some trade-offs and decide how much work you're going to put in and what approach is best. So I would like to propose to you that approval testing is often a good approach when the design is bad, because it allows you to make the test a little bit more writable. You might not necessarily need a really good requirement spec or access to someone who knows what the system can do. And it can help you to just write a lot of tests to cover a lot of combinations in the case when your code is a big blob with no design. So that's basically the conclusions that I've drawn from my studies of the Gilded Rose refactoring kata. And I do encourage you to give it a go. It's a fun exercise. Okay, thank you very much for listening. And it's time for the Q&A. So I think I'm going to go back to the StreamYard thing now.
Thanks a lot for this presentation. So let's see what kind of questions we have. So I will start with that one. So it's for Valentina. How do you decide whether or not to use approval testing on a legacy project?
Yeah, so I guess because I'm quite a fan of this approach, you may have gathered, it's usually my first choice, actually. So I mean, it's such a good way of getting a handle on legacy code. And legacy code doesn't have these small units. And when you've got a larger unit, it's got more than one outcome, usually. It does more than one thing. So these very fine-grained unit tests are just a pain to write because you need so many of them. So I find approval testing, anytime you need more than one assertion, use approval testing.
That's definitely a good point that you raised about starting with it. In other words, firstly starting with approval testing before you get to later writing unit tests or something, because for example unit tests are somehow dependent on you need some kind of level of composability, or you need to use dependency injection, and here we could have a legacy project where, for example, there's no dependency injection, or it could be not possible, for example, to write unit tests at all. And this is a nice way to protect us.
Yeah, so that's kind of one of the things with this, that there are always trade-offs. And if your design is very bad, then approval testing starts to look much like a better option. But once you've done some refactoring and you start to write new features with TDD and you start to write smaller, more composable objects, then of course you want to write small and composable, better unit tests. But that doesn't mean that that can't coexist in the same test suite with approval tests, actually. You need more than one kind of test to get the coverage you need to support refactoring and development.
And I have another follow-up question regarding this topic, and it's great how you're a fan of this and that we have a chance, for everyone to learn more about approval testing. So let's say you write approval tests, which give you that basic protection, and then you write unit tests and make your software more composable. And then now you have essentially same logic tested in some approval tests and in some unit tests. What do you then do with the approval tests? Do you retain them or do you get rid of them once you've transferred it over to unit tests?
Of course, it's a trade-off. I mean, if these tests are fast and they don't cost you much to maintain, then maybe you just keep them around. But if they are turning out to be slow or difficult or painful in any way, and you think they're redundant, I mean, maybe you're better off without them. It's always it depends kind of a question. But I don't think you can kind of categorically say that because it's an approval test, you must have a long-term goal of removing it. They can coexist with other kinds of tests, and they as I said, they're often for larger pieces of functionality, and sometimes there are bugs that only show up when you test a larger unit. So you might want to have some of them as well as your classic small unit tests.
Yeah, great points.
And I also think the good thing about approval tests is you basically don't need a lot of thinking. So you don't. If you analyze the requirements first, you need to understand them first and how everything works, and then figure out what could the code be about from the requirements and stuff. But if you just write approval testing, I always feel like it's like having a sledgehammer and basically going through the code until you finally hit the bottom, and then you assert whatever you get there, and you don't actually need to understand anything of the code yet, just so that you can basically have a construction where you can then start refactoring and moving stuff out, and then you start understanding what actually is happening in the code. That's at least my experience.
Yeah, I mean, if you do have a spec and you do have an idea about what the code is supposed to do, I think that's obviously a benefit, because you can perhaps be a bit more directed about the values you feed in to get the coverage you want. But yeah, sledgehammer. Yeah.
In your opinion, just quickly to this one, in your opinion, in order to start with refactoring, do approval tests enough? Do they give us enough security so we wouldn't break this big piece of functionality?
Well, you want to avoid introducing bugs while you're refactoring. That's kind of a pretty basic need. And there are some refactorings that you can do with very little test coverage because they're supported by tools and the compiler is likely to find any errors you make. So it's not an absolute rule you must have tests before you refactor. And then it's always a judgment call about, well, how good do my tests need to be to give me the confidence that I haven't broken anything for the refactorings I'm attempting. So when I was looking around the internet, looking at Gilded Rose solutions, I found quite a lot of people were starting the refactoring with pretty poor tests, actually. And you can maybe get away with that. But in some systems, that would be a disaster to introduce a bug. You really want to have very good tests or very good security. You want that predictiveness, which is a really important aspect, but at the same time, tests supporting refactoring have to be fast. So that's another restriction. You can't rely on the manual QA to find your refactoring mistakes. That's generally a bit too long feedback loop.
Cool. So any other points? Else we can continue with the next question, maybe.
Take the next.
This maybe a personal one. Did you ever manage to convince Dave Farley that approval tests can be TDD?
Oh no, I wish I could say I had convinced him, but no, I don't think he doesn't. He hasn't responded. I mean, I spoke to him this interview that we recorded back in like August, and I was kicking myself after that because I hadn't really made my points very well, I think, and he was still skeptical at the end of that conversation. So I made all this video to try and convince him and show him and the rest of the world how it's supposed to work. But I haven't had a conversation with him since, and as far as I can tell, he's still skeptical. So that's the thing. He's a very busy person.
Mm-hmm. This is an interesting, I think, question. Maybe if you could summarize for us what were some like key perspectives of how did Dave Farley view it versus how you viewed it, just so that we get like a short overview.
Oh yeah, the gist of the argument. Yeah, absolutely. So I've just shown you approval testing here for adding tests for legacy code and doing a kind of characterization testing. And I think Dave Farley would agree with me that this is a good use of this technique. The difference in opinion comes to developing new code and doing a kind of TDD where you specify the behavior that you want using an approval test. And of course, in an approval test, before the code exists, there's nothing to verify. You can't call the function and store a result. So the tests end up being completed after the functionality exists. You can't hit approve until the functionality works. So it doesn't look like test-driven development because it looks like the test is written afterwards. And so Dave Farley's like, oh, these tests are self-referential. They're not specifying the behavior. They are characterizing the behavior. That's different. That's not TDD. So that's kind of his argument, as I understand it, at least. And my argument is, no, you've got this all wrong. you can absolutely start to specify the behavior with an approval test. But you don't start with something that's finalized and approved. You start with a sketch. You start by thinking about, well, what will this look like when the functionality is there? What is the sketch of how it's going to look? And you either have that sketch just in your head, I'll know it when I see it and then I'll approve it, or you actually physically write that sketch on a whiteboard or in a file somewhere. And then you can always work out, am I getting closer to that? And that can absolutely inform your design decisions. So I would, I use these kind of tests for new developments as well. And I don't think that there's this kind of big gulf between that and regression testing. So.
Great. So next question we have here is from Thomas Stroud. With combination approvals, how do you usually come up with the input values for the test?
Okay, so I was trying to show you that I was just reading the code and working out what needs to vary in order to reach the lines of code that I want to cover. And so you look at the if statements and see, well, what properties is it checking? So what data do I need to have? So it's in that sense, it is completely self-referential. It's just referring to the code and how it works.
I also thought about that. Could that actually be done by AI or something? You just paste the code in and then it gives you the parameters out that you need to approve. Did you ever try that? I
haven't tried that. It's an interesting idea. Yeah, because I mean, it's fairly mechanical. You're analyzing the code and what it does and looking at what needs to vary to reach the code. I mean, the Gilded Rose is a very small problem with a very constrained number of things that vary. So real code is more complicated. But yeah, my experience is still fairly similar, that it's quite mechanical. Maybe it could be automated. I don't know.
Yeah, it is an interesting thing, like, how to come up with the input values. And what I found really useful in your presentation was how you use the code coverage in a useful way for legacy code that you were looking at essentially what are the uncovered lines. So basically you were looking at, hey, if this line is not covered, what do I do so that this line does become covered? So I noticed that was something that you used, for example, to come up with the input values and using not just line coverage, but also branch coverage. So that one was especially really useful to get into all those if statements. And I mean, coverage can be run fast. So we can get that kind of feedback fast as we continue on with the input values. And you also mentioned mutation testing as well on top of code coverage. So that was my understanding of your strategy in terms of choosing the input values.
Yes. And you get pretty good tests just from the statement coverage, but to really, I think, be very sure that you're not going to break stuff when you refactor, it's nice to have even more. I mean, mutation coverage, those can be very slow to run, mutation tests. So, but I just do some by hand, usually trying to predict what refactoring mistakes I might make, put those mistakes in and see, did my tests catch that, you know? So you can do a certain amount just by hand.
Cool. So next one is from Wolfgang. So tips for more videos or articles to learn more about approval testing in different languages, maybe also in different frameworks.
Yeah, so of course, the approval tests that I showed you there, that was Java. But there's an equivalent framework for lots of other different programming languages. If you go to approvaltest.com, you can find a list of them all. So there is absolutely tools for this for other languages. And then there's, of course, text test, which is another approval testing tool that I also work on that I haven't shown you today, but that works. It will test anything that you can execute on the command line. So it really is an approach that works with any kind of programming environment, really. So tips for more articles and so on. Well, my YouTube channel is one of the sources. Llewellyn Falco has made a few videos, I think. Some of them are a bit old these days. But basically, if you look at the people who develop these tools are also using them in their companies, and they often write articles and stuff about their experiences. So there is a community out there of people using these approaches. And I think you can find them by finding the people who write the tools and finding out where they hang out, basically.
Maybe also, what makes approval tests hard to write? I mean, is there something that makes it harder to write? I mean, the Gilded Rose is quite like you just get through, but if you have like abstractions that are somehow don't make sense and stuff, does that make it harder to write the approval test?
So you're asking about what aspects of the code might make it hard to write. I mean, that's the problems I see are not usually to do with the code so much as the people not understanding the design principles that you need to have for approval tests. So like I was pointing out, creating a printer, being in control of the text that you're approving, and not just approving any old log that your system happens to produce that's full of stuff that's totally irrelevant. And I think there's this tool Jest that has this snapshots thing, which is kind of similar, and people think that because they've used that, they understand approval testing. But it's it works slightly differently. The community who's built the approval testing tools is not the same as the Jest community, and they talk about printers, they talk about reporters, they talk about designing that text, they talk about other stuff to do with how you design the tests to make them maintainable and how to make them actually not fall into those failure modes that you easily get into, to do with basically not being in control of the text that you're approving and not being in control of analyzing the failures, because you do get multiple failures with approval tests. One change causes multiple failures, and you need a way to handle that with the tooling. in my opinion. So there's a lot going on in the approval testing community about test design more than it's not so much about how you design the system you're testing.
Yeah.
I would like to follow up. Sorry, Oliver.
No, it's good. Go.
I would like to follow up on Oliver's question regarding the challenges in approval testing. So some examples where people might have challenges, and I'm interested in your perspectives, is let's say we've got non-determinism. So suppose that there's some business logic that, let's say if it's after 5 p.m., that there's going to be a price discount that's going to be applied. So that's one example of, let's say, non-determinism. Another case could be that there's some slow running IO resource, because I mean the software is, let's say, there's no abstraction at all. So every time with all those hundreds of combinations, we're having, let's say, slow running IO. And last question is also, again, with IO, where the IO itself might be fragile or non-deterministic. For example, we're communicating with some external REST API. Maybe sometimes it's available, sometimes it's not, sometimes it gives some results, sometimes another one. And all of this happens in legacy code bases where everything is coupled. So those are some examples of challenges. I'm not sure, Oliver, if there were any others that, or Alina, that you could think of, but those are some that come to my mind. So I'm interested in your perspectives.
Yeah, that was several different problems. Yes, we can talk about that. So the first problem you mentioned was that the code depends on the current time, and it behaves differently depending on what time of day it is. And that's a problem with any kind of automated test. Is going to run into difficulties that if you can only run it before 5 p.m., then it's not a very good test. So you need to be able to control the time in some way. There's lots of techniques for that. You mock or fake the current time for the tests. The other thing that happens, of course, is that it then it outputs the current time in the text that you then approve. That can happen. It's a slightly different problem, actually. It's that the logic is the same, whatever the time is. It's just printing the time. And of course, it changes every time you run the test, and then the approval fails. So this is a well-known problem. It's the same with it prints out IDs, database IDs and stuff that change all the time. You need a concept of a scrubber. If your printer is not able to ignore and fail to print things that change all the time, you need a scrubber that takes the output from the printer and scrubs out all of the things that change. So that's one of the concepts from the approval testing. Okay, so that's times. The next thing you mentioned was it IO, slow IO?
Yeah, slow IO or non-deterministic IO or fragile IO, like sometimes it's connection established, sometimes not.
Yeah, so again, that's a problem for any kind of automated tests. You want your test to be deterministic and not fail randomly because the network was slow, or you also want it to be fast. You don't want it to have to wait for those slow resources. So again, you could use a fake or a mock or something to replace that thing. And a technique that I use a fair amount is capture replay mocking, where you record the interaction and then you replay it in the test. And I think people have used this and call it different things, but that's one way to make your test reliable. And then, of course, if the external resource changes, you need to re-record it and update your test. So these are all techniques which are not entirely specific to approval testing, but
I think the part of original question of Oliver was also wrong abstractions. If you would handle it separately, like with refactoring, for example, or can you still use your standard techniques without getting rid of these abstractions?
Well, I mean, that's if the abstractions in the code are wrong, that's like in the Gilded Rose, there are no abstractions for important concepts. So the basic strategy was to put the tests around the outside so that all the mess is in the middle, and then you can refactor and create those abstractions and not need to change the tests because they're outside. So that's kind of my philosophy. Just test a bigger piece so it doesn't get too close to the design you want to refactor. It doesn't get too coupled to the design you're refactoring. Is that? Yeah.
Sometimes you also get like static functions that you can basically not mock away, and you just have to somehow live with it. But how much would you change the code to make it testable, also for approval tests, like changing stuff from static to non-static, for example? But where do you draw the line, maybe?
I mean, the approval testing tool I just showed you, it works within the code. It's compiled with the code and it calls the methods in the code. So it is in some sense constrained by the design of the code. Text test works at the level of public interface to the code. So if it's a REST API, it will go through the REST API. If it's a command line tool, it will call it on the command line. If it's an executable, it will call, yeah. So and then you're not constrained by the design of the code at all. You're only constrained by the design of the public interface to it. So that is probably where I'd start. If the design inside is really horrible and I'm going to refactor a lot of it, then I want my tests as far away from that as, outside the code even. But then, of course, you run into that it can be slow because you're running a lot of code. And then you might need to do a lot of work to put the whole thing into a test harness where it will take advantage of you can optimize it for a lot. Yeah, this is a whole other talk that I do about text tests and how you get a system and put it in a harness and make it possible to test this way. But yeah, the basic, if you can avoid code interfaces and go for more stable public interfaces.
So I just had another question. Maybe it comes again. Also, I can also get that one briefly. So just a bit of thanks for the talk. It was a very nice explanation. And the Gilded Rose is a real great kata to explore and practice your refactoring. Do you have other katas which you recommend for practicing refactoring?
Oh yes, I certainly do. This is I'm very happy to answer this question. Yes, so I have a lot of code katas that I maintain on my GitHub. I'm a big fan of this way of teaching and learning software development techniques. So on my YouTube channel, I've got a playlist which is called my top code katas, which the goal of all of those videos on that playlist is to encourage you to go and find a code kata to work on. And so I go through the history of and what you can learn from them and stuff. So check out my top code katas, or just generally look on my GitHub for anything that's called refactoring kata.
Cool. Thanks a lot. So I got it. I got my question again. So when do you decide to rewrite the code? I mean, you showed how you rewrote it with TDD, but when I look at large systems, I mean, how would I actually rewrite that, even if I had the entire every Jira story there is? I mean,
yeah. So
do you
I maybe
decide
didn't
that?
say
Did you
this
do?
clearly enough in my presentation. I should have. Rewriting is usually not an option. It's usually too much work. I just wanted to really illustrate that actually, if you could, then you'd be a whole new vista of possibilities open up. But usually it's not feasible because the legacy system is too big and does too many things, and it would be too expensive to rewrite. So the incremental rewrite has more going for it. That's where you kind of ship of Theseus, they call it, where you have to basically identify an aspect of the legacy system that you can rewrite in place within. So you can kind of carve out sections that you can rewrite. But you really can't usually rewrite a whole system at once. It would be a bad idea anyway. It's too much work. You've got to get good at refactoring and isolating pieces to rewrite.
Yeah, that's actually also an experience that I had, that people just want to rewrite everything if it's not looking too good. And well, refactoring, I mean, if you get tests and everything, then you have the system already in place. You just need to structure it differently. And refactoring, you need to be good at refactoring, and that's another problem, that you don't use all the tools that, for example, IntelliJ provide. Doing it by hand is quite hard. What's your experience there?
Oh yeah, so I mean, usually when I go and coach teams, that's the first thing I have to show them. Look, I go into these organizations and like everyone has got really good refactoring tools built into the IDEs that they're using every day. And a lot of people just have no idea that they're there or how to use them. And it's just like, you've got this power tool here, just, so just showing people some of the most important refactorings and getting them to become a habit to do rename with the tool and to do extract method and find more names. And refactoring is definitely a skill that you can learn, and it doesn't take much to get a lot of value actually from the tools you probably already have.
And actually you basically need rename, extract variable, extract method, and inline. That's all you need, and then you can do all the refactorings. That just means Java is very...
Yeah, that's your basic toolkits, and the tools for Java are exceptionally good. But the tools for other languages are there, and they vary a bit, but some of them are, I think they're generally more worth having than not.
Yeah, we're very fortunate with Java, actually. I think the next one is TypeScript, and then it goes quite down very steep. So
I can just advertise. I've got a video coming out next week where I've got the same refactoring demo in 4 languages. And so you can kind of see how it works in different languages and tools.
Cool. So do you all have other questions?
Yeah, I have one additional bigger level question. It was great how you mentioned today, talked a lot about approval testing as a technique for legacy code bases. Now I have a question about the bigger picture. So suppose you have a team, they want to go from legacy code base towards a quality code base, and approval testing is, let's say, the first step in that journey. What are the subsequent steps that you help for a team to achieve, let's say, highest level of excellence?
Yeah, so often it's, the first steps, get some tests in place, get some feedback for finding your refactoring mistakes, get better at refactoring, learn some refactoring techniques, get better at design, get better at detecting code smells and identifying which refactorings are going to fix those smells and improve your design, get better at seeing possibilities in your code and how to get there in small, safe steps. These are all really important skills. And then eventually you get to the point where you're building new features, and then you need to be using test-driven development to build those new features. And that's a skill as well. I mean, really. I gave you a small snippet of some TDD there. It's a very different way to work for a lot of people. So quite often that's the progression. Tests for your legacy code, learning to refactor, better design skills, test-driven development. That's kind of, but that's a rough outline of how it might look.
Well, so thank you so much for this talk. We are already at the end of your session. It was very interesting for me. I learned so much, and I would love to talk even more about it. So for everybody that is still here, in our next meetup, we're going to see how to do clean code with artificial intelligence. So stay tuned for that. And of course, if you want to learn how to deliver quality software faster, then stay with us on our social media, and see you next time.